Good afternoon, all of you. Uh, Today we have Dr. Ramachandranayak.N.Y, Assistant Professor in the Department of Computer Science and Engineering, SDM College of Engineering, Dharwad. He has around 16 years of experience, and his area of interest is big data analysis and blockchain technology. He obtained his BE in Computer Science from SDM College of Engineering, Dharwad, and Masters in Computational Engineering and Networking from Amrita Vishwa Vidyapeetham, Coimbatore. He has obtained his PhD from NIT Warangal, and he has guided more than 50 UG and PG students. He has published more than 20 international papers, journals, in conferences also. And today he will be talking on P2P networks and protocols, which is a very much a requirement for blockchain. Thank you, sir, for accepting our invitation. And over to you, sir, now. Thank you.
Thank you, sir. Thanks for the opportunity provided to me. Thank you, sir. Good afternoon, everybody. I am Ramachandranayak.N.Y. I am from SDM Engineering College, Dharwad.
Sir, you can go for presentation mode. Becomes easier.
1 minute, sir. 1 minute, sir. Is it not visible, sir? Sir?
If it is in presentation mode, it becomes good.
No, actually, slideshow, sir. Yes, sir.
Slideshow, yeah.
Yes, sir. Yes, sir. Now, sir, is it okay? Sir?
Not yet.
Not yet, sir. 1 minute, sir. Actually, I had... No, sir. Wait.
Slides went off, sir.
Now, sir, is it okay?
No, we are not seeing the slides.
Now, I have shared this, sir. I have shared the PPT, sir. That content. Sorry.
Yeah, fine, sir. I think you can continue.
Okay, sir. Good afternoon, everybody. Today, I'll be delivering a session on peer-to-peer networks and protocols. How are they helpful in designing or implementing blockchain networks, blockchain technology. Before going ahead with session, what is the outline, what all the things I will discuss, let us consider one quote by Nicholas Carey, who is the president and co-founder of this blockchain. He says that imagine a world in which all people can trust each other. Normally, people don't trust each other. We should imagine a world in which all people can trust each other. This is a famous quote of that Nicholas Carey. With this quote, let me go ahead directly to my presentation. Outline of this session, introduction, what are peer-to-peer networks, then we'll consider peer-to-peer communication protocols, and then how are they related to blockchain. These things we'll consider in today's session. So, actually, blockchain builds on the idea of peer-to-peer networks. Basically, these blockchain networks are peer-to-peer networks only. These, in a sense, the networks, the underlying idea behind these blockchain networks, it is peer-to-peer networks only. And these peer-to-peer networks, actually they are decentralized peer-to-peer networks. These are decentralized peer-to-peer networks. We have different types of peer-to-peer networks. We'll definitely see as we proceed. At the moment, we can understand that blockchain networks are decentralized peer-to-peer networks. The meaning of decentralized is each node has a copy of the ledger. Each node has a copy of the ledger. In the sense that ledger is not maintained at the central level. It is not something like a bank. It's not something like a bank. Each node has a copy of the ledger. What are these ledgers? All those things we'll consider as we proceed. And we have types of blockchain networks also. One type is open blockchain networks. They are permissionless blockchain networks. If you relate them to peer-to-peer networks, at the time we can say that any client can sync to network and begin to participate in that blockchain working. So this is the linking between the relationship between blockchain networks and peer-to-peer networks. So now we'll consider what are these peer-to-peer networks and what are the communication protocols, types of communication protocols which are followed in peer-to-peer networks. All those things we'll consider. Okay. So what are these peer-to-peer networks? So in these peer-to-peer networks, we'll consider the different definitions, characteristics, the types also we'll see, structured and unstructured. We consider these topics under these peer-to-peer networks. Let us consider some definitions for peer-to-peer networks. As per Intel peer-to-peer working group, one definition is the sharing of computer resources and services by direct exchange between systems. We should look into keywords here. The sharing of computer resources, the resources and services. The resources and services are shared. And how are they shared? By direct exchange between systems. There is no intermediate point. There is no intermediary. Direct exchange between systems happens. Through that direct exchange, computer resources and services are shared. This is one definition. It is by Intel peer-to-peer working group. And we have one more definition. The peer-to-peer networks connect many end hosts. These hosts, they are also called as peers in an ad hoc manner. One more characteristic we can understand here. The way the end hosts, peers, are connected, that way it is in an ad hoc manner. There is no systematic way of connecting those peers. Of course, there are different ways. One possibility is connecting them in an ad hoc manner. Third definition is a distributed network architecture may be called a peer-to-peer network if the participants share a part of their own resources. If the participants share a part of their resources. These shared resources are necessary to provide the service offered by the network. It is something like a producer-consumer problem. Resource providers and resource consumers. Sometimes a participant can be resource provider. At other times, it will be resource consumer. So this is third definition of peer-to-peer network. And common to all these definitions is we can see that in all these definitions, of course, those definitions are just representative definitions. Some of the definitions, not all. We cannot list all of the definitions. So common to all these definitions is these definitions agree on sharing of resources. So resources are to be shared among the nodes of the peer-to-peer network, and the communication between peers in the network, it is direct communication. And when there is a direct communication, definitely centralized control is not required. So these are the characteristics, what we can say. These are the characteristics or properties of peer-to-peer networks. Of course, we can list the characteristics. Sir? Yeah. So these definitions agree on sharing of resources, direct communication between peers, and no centralized control. Before going ahead with other things, let us say what is peer. Peer, it is an entity with capabilities similar to other entities in the system. It is an entity with capabilities similar to other entities in the system. In the sense, all the entities present in the system are equally powerful. All are having equal capabilities. So it is a peer. It is that node. All the nodes are they are called as peer nodes. Okay. So P2P systems are popularly actually they are meant for file swapping purpose, in the sense for distributed content sharing. Earlier they were developed for distributed content sharing. A number of peer-to-peer networks, they have been developed and they have been deployed also. Some of the popular peer-to-peer systems are Napster, Nutella, Fast Track, BitTorrent. And these are some popular peer-to-peer systems. There are others also. Okay. So with this idea, let us discuss what are the characteristics of these peer-to-peer networks. We can list here like this: resource sharing, networked, decentralization, symmetry, autonomy, self-organization, scalable, stability. These 8 characteristics, let us discuss
Sir,
one. Yes, sir.
your slides are not moving here.
One
The first slide ಅಲ್ಲೇ ಇದೆ ಇನ್ನು.
I'm sorry, sir. 1 minute, sir.
I couldn't
now
see
it's
the slides. Till now, the slides were not been shown.
Yeah.
Sir, now?
Yeah, now it's.
Yes.
Is it the slide
Now yes,
now?
sir.
Now,
You can continue.
Okay, sir. Okay. Thank you, sir. Sorry, I thought it is visible from that side.
No.
Sorry.
Yeah, I think it was not moving. That's all.
Oh,
Fine, sir. Now yes.
Okay, sir. Thank you. So the characteristics of peer-to-peer networks are, we can list them like this: resource sharing, networked, decentralization, symmetry, autonomy, self-organization, scalable, and stability. Let us discuss these characteristics one by one. First one, resource sharing.
टाइम होता है ना, कितने घंटे का रहता है?
Each peer contributes system resources to the operation of peer-to-peer system. Each peer it contributes its own resources. It will help others so that peer-to-peer system operates properly. And ideally, this resource sharing by a particular peer, it is proportional to the peer's use of the peer-to-peer system. In the sense, if I am using 10% of the peer-to-peer system, I should share only 10% of my resources. That is the ideal situation, but that doesn't happen. Okay, so all are capable, all are equally capable. So So this is resource sharing, first characteristic. And second characteristic is networked. All the nodes are interconnected with each other in the peer-to-peer system. The full set of nodes, they are members of the connected graph. All the nodes are interconnected with each other. We can picturize this one in this fashion. Like this, we can picturize it. This interconnection. Okay. And then third characteristic is decentralization. The behavior of the peer-to-peer system is determined by the collective actions of peer nodes. How peer-to-peer system behaves, it is determined. The performance of the department, it is determined by the performance of all the faculty members and all the staff members. So here also same thing, the behavior of the peer-to-peer system is determined by the collective actions of peer nodes. There is no central control point. Only one person cannot be held, only one node cannot be held responsible, because all are equally powerful, and there is nothing like central control point here. This is third characteristic, decentralization. Fourth one is symmetry. In the sense, the nodes assume equal roles in the operation of the peer-to-peer system. That is ideal situation, assuming equal roles. However, in some designs of peer-to-peer networks, there are some special nodes, special node peer nodes. The peers, they assume special roles such as super peers or relay peers. That is in some designs. Ideally, the nodes assume equal roles in the operation of the peer-to-peer system. And this is fourth characteristic, symmetry. Fifth one is autonomy. Each node in the peer-to-peer system is autonomous. Its participation, its action is determined locally. As there is no central control point, there is no single administrative context for the peer-to-peer system. Okay, so each node is autonomous. Then self-organization. Sixth characteristic is self-organization. The organization of the peer-to-peer system increases over time using local knowledge and local operations at each peer. So no peer dominates system. All are equally powerful, and they can take care of themselves. Seventh point is scalable. This is a prerequisite of operating peer-to-peer system with millions of simultaneous nodes. The peer-to-peer system, it should be scalable one. Even if we add another 1,000 nodes, it should work properly. And whenever a new node is added, the response time should not grow, say, in quadratic way or exponential way. The response time should not grow more than linearly as a function of the size of the peer-to-peer system. It should be the number of nodes. The response time should be proportional to the number of nodes present in the system. Last characteristic is stability. The peer-to-peer system should be stable one. It should be, even if a node is added or deleted, still it should continue to work. It should maintain its connected graph, and it should be able to route deterministically within a practical half count bounds. So these are the characteristics of peer-to-peer networks. And let us consider the different types of these peer-to-peer networks. We have basically two types, structured and unstructured peer-to-peer networks. What do you mean by structured? In structured peer-to-peer system, connection among peers in the network, the connections are fixed. And when connections are fixed, definitely the nodes, they maintain information about the resources the neighboring nodes are having. So who is my neighbor? What are the resources he can share with me? All those information I'll be having. So because the architecture, the connections among the peers in the network are fixed. And when the network is fixed, connections or when the architecture is fixed, definitely the data queries, if I want some data to be fetched, when it is queried, the data queries can be effectively directed to the neighbor peers. So I will send, I will request for the resource. I will send that request to my neighboring peer node, and if it has, it will respond. Otherwise, it will send. It will pass on that request to its neighbor. Like that, it proceeds. So it is a systematic way of organizing peers, nodes in the peer-to-peer network, structured. In case of unstructured, the connections are formed arbitrarily, either in a flat or hierarchical manner. In that situation, if there is a request for content, some content, if a node requests for some content, at the time the nodes have to send that query to other nodes in the network through several techniques. The techniques which are followed for fetching the required content, some of the techniques are flooding, random walking, expanding ring. So these are the techniques.
Sir, PPT not visible again.
1 minute, sir. Sir? Sir?
Yeah, now yes.
Okay, sir. Sorry, I don't know. Maybe there is some network problem from our side
Fine.
here.
Now yes, sir.
Yes, sir. Thank you, sir. So, if the peer-to-peer network is unstructured one, at the time, if a node requests for some content or if a node requests for some resource, at the time the neighboring nodes or the nodes, they pass on that query to other nodes through various techniques. It can be either through flooding or random walking or expanding a ring. So these are some techniques which help us to get the desired content. Within that unstructured peer-to-peer networks, we have centralized unstructured peer-to-peer networks, decentralized or pure unstructured networks, and combination of them, that is hybrid unstructured peer-to-peer networks. So let us consider these three types of unstructured peer-to-peer networks. First one, centralized unstructured. Here there is a central entity, and this central
Excuse me, sir. Sir,
Yes,
excuse me, can you change the slide? I see that slide number 20, it shows centralized unstructured network as I see on the side of the PowerPoint. So can you, I mean, the next slide or whatever slide you want, I mean,
Sir,
required.
ನೀವು
Can
ಅದು
you?
slide move ಮಾಡಬೇಕಾಗತ್ತೆ. You might have to go to the next slide.
No, I have moved, sir. Actually, I have
It
gone
is
to.
showing in ಇಲ್ಲಿ ನಮಗೆ unstructured ಒಂದೇ ಬರ್ತಾ ಇದೆ.
I'm sorry, sir. 1 minute, sir.
Flooding, random walking.
Yeah, yeah, sir, sir. I don't know the reason. 1 minute, sir.
Now yes.
Wait, sir. 1 minute. Sir. Sir, now is it visible?
Now yes, sir. Yes, sir. Yes, sir. Please continue.
I think now it is not showing in the slideshow mode.
That is fine, sir. What you can do is you can keep moving the
Yes.
slide.
Okay, sir. Okay. Yeah. First, unstructured peer-to-peer networks is centralized one. So in this case, it is a variation of this peer-to-peer networks. A central entity, central peer node is present here, and that central entity, it takes care of indexing and bootstrapping the entire system. All the nodes are not equally powerful. One node is designated as a central entity, and that takes care of indexing and bootstrapping the entire system. So this one, unlike a structured approach, the connection between the peers in the centralized is not determined by the central entity. Here the connection, it is not determined by the central entity. An example for a centralized unstructured peer-to-peer network is BitTorrent. Sir, is it visible now?
Yes.
Second one, decentralized or pure unstructured peer-to-peer networks. Is it visible, madam?
Yes.
Thank
Yes.
you, madam.
Yes.
Thank you. So this decentralized or pure unstructured, it is an overlay network. Basically, an overlay network is a logical network. In this case, there is neither a central server nor there are preferred peer nodes. There are no special nodes here in case of decentralized or pure unstructured peer-to-peer networks. One example for this one is Nutella. Okay, and hybrid unstructured peer-to-peer networks. It allows the existence of infrastructure nodes, that is super peers, super nodes or overlay nodes. And one more thing is, in case of hybrid one, a node can change roles over time. A regular peer node can become super node. It is something like rotation of the post. So it is something like that one. So a peer in such a network can change roles over time. A regular peer node can become super node. An example for this hybrid unstructured node is Kaja. Okay, so this is third category, third type of unstructured peer-to-peer networks. And if you want to actually search for a particular, if you want to fetch some content, or if you want to access some resources, at the time these peer-to-peer networks, they maintain they maintain information in the form of hash tables. They are called as distributed hash tables. As the name itself says, it is a distributed version of hash table structure. Each peer, each node stores key value pairs, and use of this one is there has to be efficient insert, delete or lookup key value pairs. And the core operation, it is finding a node, responsible for a key. Which node is having a particular resource, or which node is having particular content. So that node, it has to be determined. So where it is present, how many hop counts, how many hops are to be made to access the data from that particular node. So that is the core operation. For that purpose, what is done here is we map key to node, and we efficiently route that request to that particular node. And one more thing is this distributed hash table. It should allow for frequent node arrivals or departures. It should be a dynamic one. It should not be something like fixed. It should not have fixed number of nodes. It should be dynamic node. So the desirable properties of this distributed hash table is, the desirable properties are keys should be mapped evenly to all the nodes present in the network, so that load balancing can be ensured. And one more thing is, one more desirable property is, each node should maintain information about only a few other nodes. I should not maintain information about the nodes present in the entire network. It is not feasible. If I try to know where everybody is going, I should not do like that. Maybe where are my friends? What are they doing? If I know it, that is sufficient here. So each node should maintain information about only a few other nodes. The consequence of this desirable property is the peer-to-peer networks, it becomes scalable, and advantage is low update cost. If a new node comes, at the time updation can be done quickly. Okay. So that is another desirable property. Third desirable property with respect to distributed hash tables is messages should be routed to a node efficiently. In the sense, if a particular node requests for a particular resource, it should be routed to destination node in less number of hops. It should not traverse the entire network. Okay, that is another desirable property. And last desirable property is node arrival or departures should only affect a few nodes. It should affect only a few nodes. When I maintain information about only few nodes, this property can be ensured. Node arrival or departures should only affect a few nodes. So these are the desirable properties of distributed hash tables. Okay. So that is about peer-to-peer networks. Now let us consider the protocols, the underlying protocols which are followed in peer-to-peer systems. If you consider a node, a peer node, within that a process, so P2P processes execute layer N protocol to provide service to layer N+1. So we are having, it is something like our OSI reference model, N-1 peer process here. And this is, if you see, this is a source machine and this is the destination machine. And if there is a request from source machine to destination machine, at the time N peer process we are having at this level, at this layer, at the time peer-to-peer processes execute layer N protocol to provide service to layer N+1. So a layer provides services to its upper layer. A layer provides its services to upper layer. How it is done, that we can understand here. So layer N+1 peer calls layer N. layer n+1 peer process. It calls layer n peer process, and it passes service data units for transfer. What type of service is required? What type of resource is required? What is the content required? So that is transferred from layer n+1 process to layer n process, okay, in the form of service data units. And the layer n peers, of source machine and destination machine, they exchange protocol data units, PDUs, to effect this transfer of, transfer, okay. And then layer n delivers service data units to destination layer n+1 peer. So this is the way the communication happens between source machine and destination machine, or one peer to another peer in the peer-to-peer system. We can note that a layer, a process which is present in the current layer, it can provide services to the process which is present in the upper layer. So if a layer wants service or resource from other peer, it will send request to its lower layer, lower process. Through that one, service is met, service requirement is met. The service model, it specifies the service model. It specifies the information transfer service the layer n provides to layer n+1. The service can be connection oriented or connectionless. So what do you mean by this connection oriented transfer service? In this case, the three steps: establishment of connection, message transfer phase, and disconnect phase. So establishment of connection, connection must be established between layer n+1 peers, and for this purpose, layer n protocol must set initial parameters, example sequence numbers, and it must allocate resources. Examples for resources can be buffers. Okay, so once the connection is established, then the SDUs can be exchanged. The SDUs can be exchanged. Once that exchange is over, that disconnect phase can be initiated. Okay, an example for this connection-oriented transfer service is TCP. And connectionless transfer service, in this case, as the name itself suggests, there is no connection setup. We simply send a SDU, and each message is sent independently. And when each message is sent independently, we must provide all address information per message, because there is no link between the different messages. There is no link between there is no interconnection between the messages. So every message should carry all the address information. The advantage of this connectionless transfer service is it is simple and it is quick. Example is UDP. Okay. Yeah. Now, with these ideas about peer-to-peer networks and peer-to-peer communication protocols, now how are these related to blockchain? That we'll consider now. Yeah. At the beginning, I told that blockchain builds on the idea of peer-to-peer networks. So basically, blockchain networks are peer-to-peer networks, and in case of blockchain, we are having the decentralized peer-to-peer networks. Each node has a copy of the ledger, and we have a category of blockchain networks, open blockchain, and they are permissionless. Any client can join and start participating in the blockchain. Okay, so now actually interest over this interest for this blockchain technology, it is exponential. Earlier maybe this slide, the year may not be properly visible. Recently the interest it is increasing in the exponential manner. If you refer even normal newspaper, somewhere you can see that there is word blockchain or Bitcoin, like that. So interest of the people is growing in this blockchain technology or Bitcoin. So what do you mean by blockchain? Blockchain is a system containing peer-to-peer distributed architecture, and there are decentralized peers. Transactions are involved. There is an encryption process and immutable log file, which is called as ledger, and the different nodes they follow consensus mechanisms, and smart contracts are followed. So that is the blockchain system. Okay. Another definition is a blockchain is a digitized, decentralized public ledger of all cryptocurrency transactions. No, actually, this blockchain technology, it was first introduced in a white paper entitled Bitcoin, a peer-to-peer electronic cash system by Satoshi Nakamoto in 2008. This ledger, what you can say, you can consider it as Internet of Records. Okay. Actually, in this Bitcoin white paper, he clearly mentioned that it makes use of a peer-to-peer network. In the sense, all the nodes are equally powerful. Purely peer-to-peer electronic cash or digital asset transfer system. He mentioned about the characteristics of that such a system. Okay. This is the first popular implementation of blockchain and is attributed as birth of today's blockchain industry. Later on, that Bitcoin, later on, additional blockchains have also been popularized. Ethereum, various hyperledger project solutions, and blockchain-like solutions also have been popularized. They have been mentioned. Okay, they have been proposed. So this is the paper. This is the paper which led to the development of Bitcoin or blockchain application. Okay, yeah. Bitcoin actually it is simply a means of sending and receiving numbers to and from addresses. This which is the first blockchain implementation. It is an open source peer-to-peer payment network. It uses digital signatures and encryption, and the security and freedom it is provided through decentralization, and it also makes use of public-private key encryption. Little bit of history and characteristics. In 2009, first Bitcoin was produced, and it followed peer-to-peer approach. That is, there are no middlemen. It is a decentralized one, so there is no central server, and transactions are verified by network nodes. The transactions are verified by network nodes. Other nodes. If I perform a transaction, if I'm a part of a network, at the time my transaction is verified by other nodes of the network, and that verification is done using cryptography through mining. And these transactions, once they are verified, they are recorded in a ledger, and that ledger is a distributed ledger. Each node of the Bitcoin has each node has got that ledger, and mining, the work to be carried out is a proof of work. It uses a proof of work system. Okay, this Bitcoin. Basically, Bitcoin is among the greatest inventions in history, and the rest of us need to mainly focus on trying to understand what that could mean for different fields, rather than complaining about this or that mostly imagined problem. So even now, this Bitcoin is or blockchain technology, it is not acceptable to in most of the countries. It is still facing a lot of hurdles, regulatory problems. But those who are dealing with it daily, they say that it is safer one. We need not worry about that one. But still a lot of regulatory hurdles are there. Okay, we can think of this Bitcoin as an electronic asset, or we can also think of it as a digital currency. How the technology behind this Bitcoin working is a network of computers keeps track of Bitcoin payments and adds them to an ever-growing list of all the Bitcoin payments that have been made. And once that list, we call it as Bitcoin blockchain. The file that contains data about all the Bitcoin transactions is often called a ledger. And how value of a Bitcoin is determined? It is created, or it is determined through transaction processing. And that transaction processing, it is called as mining. All the nodes perform this mining. Okay, those nodes are organized in the fashion of peer-to-peer networks. Okay, so this is the difference between centralized ledger and distributed ledger. Sir, sir. One minute. Yeah. One minute. Yeah. We were here. Yeah. This is the difference between centralized ledger and distributed ledger. Then we are having blocks. Each blockchain consists of blocks, and each block contains the data, its own hash value, and a pointer to the hash of the previous block. And we can maybe in the last 2 days, people have gone through these details of this blockchain. So the blocks are connected to each other through linked list, and that hash contains pointer. That hash, in the sense, it points to next block. It points to next block. Okay, this is you can see there are three fields in each block: own hash, previous block's hash value, and actual data. And how the blockchain works, all those things, I think they have been discussed in the last few sessions. These characteristics and benefits. There is a public ledger system that records and validates. So it is because of this one, it is secured one and reliable and transparent, this public ledger system. And transactions, they are authorized by miners. Because of this one, immutable and hacking resistance. That blockchain, it cannot be, that underlying network, it cannot be hacked. And there are no central coordinating point. Okay, real-time settlement, operational cost savings, and as I told, it is distributed one also. So because of this one, there is reduced risk. There are three types of blockchain networks: consortium, private blockchain, and public blockchain. In consortium blockchain, it consists of a group of members. Group of members control this blockchain. Verifying and adding records to the blockchain is based on consensus mechanism by a pre-selected set of nodes. It is something like related decision making. Okay. Then we are having a private blockchain and a public blockchain. And then the building blocks of blockchain are hash functions, hash chains, proof of work, and digital signatures. So these are actually there are properties of hash functions. Deterministic one, it should be pseudo random one-way function. That is, if I am given with x, I should be able to calculate h of x. But if I know h of x, I should not be able to calculate x. One-way function, and two values should hash to two different hash values. And the hash values, they consist of digits and letters. Different standard hashing algorithms, MD5, SHA1, SHA256, SHA512. And Bitcoin makes use of this SHA256. Okay? And there are different ways of hashing: independent hashing, repeated hashing, combined hashing, sequential hashing, hierarchical hashing. The different words, they are independently hashed in case of independent hashing. In case of repeated hashing, two levels. It is not just one level. Hashing of given word with using one function, and whatever hash value we have obtained, that in turn is hashed using another function, repeated hashing. Then we have combined hashing. Okay, then we are having sequential hashing, then hierarchical hashing. Like this, different hash function. In the sense, the way we can do that hashing. Okay. Then hash chains. Each block, it points to next block through a chain. Hash chains. Okay. If there is an attack, at the time definitely there will be change to the information, change to the hash value. Through that one, we can come to know that there was an attack, and we can take care of the things. Okay, and attacker changes the payload here. Okay. Then proof of work. Proof of work is how to get bitcoins, how to get the rewards. If I want if I want to be rewarded, I need to solve the puzzle. I need to give the solution to that puzzle. That is the proof of work. If that is acceptable, then I will be rewarded. This is proof of work. Okay. It is something like, I want you to do a big computation, and at the same time I want you to prove you did it. And when it is done, I should not spend much of time in checking the proof. I should not spend much of my time in checking the proof. So at the time, this proof of work helps. Okay, limits the rate of new blocks. New blocks are not added quickly. They take sufficient time. So it makes attempts to add invalid blocks to the chain expensive. Invalid blocks are discouraged, and provides a clear way to decide between competing chains when there is a disagreement. The one with the most work wins. Whoever has done quickly, or whoever has given efficient solution, he wins. Okay. And then digital signatures. There are two properties. Only we can make our signature, but anyone who sees it can verify that that signature is valid one. And one more thing is, that signature is to be tied to a particular document, so that signature cannot be used to indicate that I have agreed or I have endorsed a different document. These are the two properties of digital signatures. So these are the building blocks of blockchain. And there are criticism also, and there are challenges associated with this blockchain, as well as with these peer-to-peer networks. It is one criticism is, it is still developing one, nascent technology, and it is uncertain regulatory status, and it consumes energy heavily, and there is no control. The security problem, privacy problem is also there. Integration concerns are there. Cultural adoption. It is something like people think that it is something like betting. There is cost involved, cost in terms of time, cost in terms of actual investing. Okay, and there are challenges associated with audit, taxes, and compliance also. So these are some challenges which are present, which are to be addressed in each country. So in today's session, in this session, I have discussed what are peer-to-peer networks, what are protocols underlying peer-to-peer networks, and then I briefly related these networks and protocols to blockchain. Any questions from the participants?
Sir, good afternoon, sir. Can I ask a question? I'm Anita Vinayak from Delhi.
Please, madam.
Sir, what is the role of SOA in blockchain? Do we use that architecture in blockchain, or are there any future decisions on the basis of SOA to be implemented in blockchain architecture?
You are talking about service-oriented architecture, no?
Yes, sir.
That service-oriented architecture, actually, it can be integrated with this blockchain technology also. That is possible, madam.
Right, sir. Yeah. So, what will be the protocols? Like here, you are talking about we talk about TCP, UDP, disintegrated peer-to-peer. What will be the architecture? How will there be any change in the protocols? What will be there actually?
No, actually, the underlying network is peer-to-peer only.
Okay.
Based on the requirement, it has to be, the network has to be modified based on the agreement between the participants of the network. The architecture, in the sense, we can change the architecture. We can design network as per our requirement.
Right, sir.
Yes.
Right, sir. Thank you, sir.
Yes, ma'am. Welcome. Any other question, please?
Good afternoon, sir.
Good afternoon, madam.
Yeah, sir, in Skype and all, are they going to use this peer-to-peer architecture only?
Yeah, actually, it is peer-to-peer network only. What you say, the requirements there are different. The requirements there are they are customized for Skype purpose. Basically, it is a peer-to-peer network only.
So it is like a peer-to-peer architecture along with this VoIP applications. Is it that Skype is going to use?
That I'm not that much sure, madam. I have to check it, madam. I'm sorry, madam.
Okay, okay. Sir.
Any other question?
I hope there are no questions. Sir, thank you very much for delivering this lecture and giving this information on peer-to-peer networks and protocols.
Yes, sir.
And
Thank you,
from
sir.
JSS Academy of Technical Education and Department of Computer Science, we thank you and acknowledge your presence here for this FTP. Thank you, sir. Thank you all participants. We will meet at 2:30 and Bhavana Rudra madam will be continuing from wherever she had stopped. The links are already been shared. Please join before 2:30. Thank you all.
Thank you, sir. Thanks.
Thank you. Thank you.
Thanks.